Hello everyone. So today I'll be telling you about a small piece of code that'll solve MNIST to 96.91% accuracy. And it won't involve any machine learning, which is the traditional approach to this problem. First of all, let's recall what the MNIST dataset is. We have a bunch of images, each of a digit between 0 and 9. The task of the code is to guess the digit based on the image. So let's get started. So I've run all of this already. I'll just be showing it to you cell by cell. So our first step is to put in a timer. So we'll print out when the notebook starts executing. Our next step is to do the imports. So we have PyTorch, we're using PyTorch. We have Torch Vision to download the MNIST data. We're using the transforms package to convert it into tensors. The next step is to use the GPU if it's available. As you can see, I'm using the CUDA device, which means I have a GPU, which was offered by Google Colab, obviously. And what kind of GPU? Well, here you see it's a Tesla T4. Our next step is to define the transformation which converts the images to tensors. So obviously we're converting them to tensors. The next step is to download the training and test data. So the training data is 60,000 images and the test data is 10,000 images. Our next step is to extract the images and the labels, convert their D types to float 32 so that we can make some floating point manipulations on them, and also put them on the device so that if the GPU is there, you can do it faster. So we have xtrain, xtest, which are the images, and ytrain, ytest, which are the labels. The next step is to check the shapes. So as you can see, xtrain has a shape of 60,000 by 28 by 28, which means there are 60,000 images, each 28 by 28 pixels. And obviously it's associated with it are 60,000 labels, which is the ytrain shape. Similarly, xtest has a shape of 10,000 by 28 by 28, and ytest has a shape of 10,000. So let's plot a few MNIST images. So here I've plotted the first 4 MNIST images. The label is the digit to which the image corresponds to. The next step is to actually write the function which is going to do the inference for us. So the point of this is that what this function does, so if I were to just highlight this part, is that given some image, right, so a 28 by 28 tensor, it returns the index of the training image that is closest to it in the sense of Euclidean distance. So we're going to compare the Euclidean distance of the given image to all of the images in the trained data and find out which training image is closest. So that's what this function does. It takes the image, it checks that it's a 28 by 28 tensor, it finds the difference between the image and all training images. Then the expected shape that we're going to get is 60,000 by 28 by 28. And then you want to reshape this tensor. So we're going to make it 60,000 by 28 times 28. All right, so we're just flattening one of the dimensions. And then we're going to calculate the Euclidean norm, or it's also known as the L2 norm, across this 28 by 28 vector dimension. All right, so that's what this line does. And I'm going to store that as distances, right? Dim equals 1 tells us to just do the norm on the 28 by 28 dimension. And odd equals 2 tells us that we're calculating the L2 norm. So at the end of the video, I'll change this to odd equals 5 and show you that it does slightly better. But odd equals 2 is the most intuitive choice. So the expected shape of distances is 60,000, a list of 60,000 numbers, telling us how far away the input image is to each training image. And then we want to return the index, which gives us the smallest distance, and hopefully that'll also be the index of the closest image, because intuitively the smallest distance is the closest image. So that's so here we have torch.argmin of distances. So our next step is to make predictions for xtest using the label of the closest train image. So we go through each image in xtest And then we find the index of the train image that is most similar to it using the function that we just wrote, closest train image. So we say for image in X-test, find closest train image of image. And that gives you a list of indices, IDX. Then we use the label of this most similar image as the prediction. So we go through indices in IDX and then extract Y train of that index. And then we have to convert that to a tensor, of course, and put it on device. And those are our predictions Y preds. Let's compute the accuracy of the prediction. So here we have, we're comparing Y preds to Y test. Then we're summing it and then dividing by the total number of predictions. And that should give us our accuracy. And here I've printed that out in percentage form. So 96.91%. So out of the 10,000 images, 9,691 are correctly classified. And finally, let's find out how long all of this takes to run. So I put in another timing cell, and it prints out that the notebook execution finished in 25.8 seconds. If I were to calculate the L5 norm instead of the L2 norm, I would just have to change odd equals 2 to odd equals 5. And let's find out what accuracy we get on that. Our accuracy of prediction is 97.32%. So a bit better. And I think the L5 norm is the one that does the best. So if you increase it any further, the accuracies will start dropping again. I'll leave a link to the code in the description if you're interested. Thanks for watching.